So now if I have voltage sources in series, the total voltage will be V1 plus V2. This is again by some trivial application of Kirchhoff's voltage law. Okay. Now let's take three cases. I apply V1 across a resistor R. The current flowing would be V1 by R. Similarly, if I have a voltage V2 applied across a resistor, the current will be V2 by R. And if I have V1 and V2 in series applied across the resistor, the voltage across the resistor will be V1 plus V2 and the current through the resistor will be V1 plus V2 divided by R, which is V1 by R plus V2 by R. Okay, the voltage across the resistor here is V1, the voltage across the resistor here is V2. Now if we think of the voltage as cause and current as effect, it could be both ways for a resistor, but if we think of the voltage as the cause and current as the effect, you see that here I have a cause equal to V1 and I have some resulting current. Here I have cause equal to V2, some resulting current, and here I have a cause that is the sum of these two. Okay. That is the cause. And if you look at the result, that also happens to be the sum of the individual results. Okay. That is, if I apply voltages V1 and V2 separately to a resistor, I get currents of V1 by R and V2 by R respectively. If I apply a voltage V1 plus V2, I will get the sum of individual currents. Okay. Now this property is known as linearity. In general, if you have any system which has a certain cause and a certain effect, I can apply different values of cause individually and I can measure the different effects. If I apply all the causes together, all the results, all the effects will be summed together. Okay, so that's the meaning of linearity. That is, if you have stimulus or stimuli which are combinations of certain values of stimulus, then the responses will be sum of individual responses. Okay, and this is known as linearity, and this will be exploited very heavily in our analysis of circuits. Linear circuits form a very large class of useful circuits, and mainly in this course that is what we will be analyzing. Okay, and any element that follows this is known as a linear element, and obviously a resistor is a linear element because if you apply a cause that is the sum of causes, you will get an effect that is the sum of effects. Okay. Now the question I have is, we have discussed three elements, an independent voltage source, an independent current source and a resistor. Now please let me know if the voltage source and the current source are linear or not. I got some responses, and some said they are linear. One person I think said they are not linear. Again, the way to evaluate this is to see whether the effect is proportional to the cause, or if you have individual causes, will the effects be summed up? Okay, when you sum the stimuli. Okay. Now let's consider a voltage source, or perhaps let me take a current source because that will be analogous to this example. Now let me copy over this whole thing. Instead of resistors, let me have current sources. Okay. Let me have a current source I naught, and here I'll have I naught, and here I'll have I naught. Now clearly the current in this case is I naught, the current in this case is also I naught, and the current in the third case is also I naught. Okay. That is, here I apply V1. The current anyway is independent of what is applied to it, so it will be I naught. Here also it will be I naught, and here also it will be I naught. So although I apply a voltage that is a sum of the individual voltages here, that is, here I have applied V1, here I have applied V2. Now, if this principle, that is, if combining the causes will give you a combination of the effects, if that is true, then this current should have been 2 I naught, but it is just I naught. Okay, so in fact, it's not equal to the sum, right? The resulting current is not equal to the sum of currents in individual cases. So this says that the current source is not linear in the sense that a resistor is linear. Okay. So what says if something is linear or not? If it obeys the principle of superposition, and what is the principle of superposition? The response to a combination or sum of inputs is a linear combination that we are talking about, is the sum of responses to individual inputs. Okay. If this is the case, this was true for a resistor, then it means that it obeys the principle of superposition, and if it obeys that, it implies linearity. Okay, so a resistor is linear, a voltage and current source are not linear. Okay, now this has nothing to do with the characteristics being a straight line. Okay, sometimes that is what is called linear, but here for us what linearity means is whether it applies, whether it obeys superposition or not. Okay, so now I have another question for the participants. We draw these IV characteristics, and I showed you that the current source is not linear, and in a similar way voltage source is not linear also. Okay, you can apply two individual currents to a voltage source, you will get some voltage, and if you apply the currents together you will get the same voltage, so that is also not linear. And we have these IV characteristics that we have drawn. So what is the what feature of the IV characteristic guarantees that the element is linear? Okay, that's my question. Now I have a number of responses. Basically, if we have a two-terminal element, then if the IV characteristic passes through the origin, that is linear. Okay. And clearly this is true for a resistor, but for a voltage source or a current source, it is not true. Okay. So resistor is linear and a voltage source and current source are not linear in that they don't follow superposition. Now just some more details of what is superposition. Let's say you have some system, okay, I will show it in an abstract way like this, and here we are talking about two terminal elements whose stimulus could be a voltage and the response current or vice versa. So let's say you have some input and it has some output. Okay, I am here talking very generally, I am not saying what system it is and what input output it receives and so on. So first of all, for linearity, y must be 0 if x is 0. Okay, otherwise you can show that it cannot be linear. Now, if x1 gives you y1, then if it is linear, alpha times x1 will give you alpha times y1. Okay, and similarly, if x1 results in y1 and an input x2 results in an output y2, an input of x1 plus x2 will result in an output of y1 plus y2. Okay. Now these are not independent statements that I am making, some of them imply the other. Okay. So these are all necessary conditions. Now this says that if you have the IV characteristic, it has to be passing through the origin. Okay.